Alright, not sure how far we're going to go today. This piece of metal I had welded up a couple years ago, and I think I was imagining putting wheels on it, because I got the holes pre-drilled for the bolts. These are 5/8 bolts, I'm pretty sure, that match the axle size of the Harbor Freight wheels that I'm using. So it'll just slide on there. Nice as can be. These wheels have the bearings built into them, which makes it nice. It's like a wheelbarrow type wheel, or for a cart or something like that. But the issue is, it'll make a great caster wheel or a coasting wheel, like it could be the front wheel of a go-kart that doesn't need to be driven, right? But there's not a convenient, obvious way to drive it. Normally, if you were driving the wheel, you'd have an axle stub come out and a flange that the wheel would mount to. Okay. So what I'm doing, and I learned this from Post-Apocalyptic Inventor. I don't remember exactly how he did it, but basically you just make a little adapter that matches those bolt patterns. Now you've got something you can put a sprocket on, right? So I did this on the 3D printer. I made this a while ago and just hadn't gotten back to it yet. So I got the hole spacing figured out, measured it out, then I added some holes that I can then bolt the next piece to. And I thought, for at least in the beginning, make this as a series of smaller pieces. Make sure this part works first. Make sure I got enough depth I can just go back into CAD and make it longer or shorter if I need to, you know, when I get it figured out. I could also remake this piece that has the bearing and just make the bearing part of the next piece. Okay, it's a possibility. Anyway, so that's kind of where we're going. So my thought is, for now, use this as a platform, maybe bolt it down to the bench here, or be able to take it back in at night, whatever. Figure out, you know, basically what I need is a spot to put this all together, bolt it up, figure out how much room do I have to put my next piece, which would be a sprocket. I need to gear down, so I would put a fairly large sprocket on here and a fairly small sprocket on the motor to slow it down. Okay, and at this point I don't know yet which motor I'm going to use. But for today, and it's going to be just like, how far can I get before I run out of options? Can I get to the point, like for instance, I don't have any belts or pulleys right now. I ordered some gear tooth belts from eBay. It looks like they might actually be at the post office today, so I might just jump in on the bike, ride, 12.5 miles there and another 12.5 back to get them, and then I'd have a starting point, because if I had the belts, then I can make sure they're the right size. If not, I can turn around and order more, and then I can start making the pulleys for the belts. The gear tooth, it's a timing belt. It's got little teeth in the belt actually, so that they don't slip usually, unless you really screw it up. But I found patterns so you can 3D print any size of pulley you need. So if you wanted to change the gear, and you could make one with more teeth or less teeth to, fine-tune your setup a little bit. So that was kind of the plan, is leave these screw holes here, make the pulley that then mounts to that. Okay, so for now, I think if I can just take one of these wheels apart, this one is currently flat, and actually, I don't even care right now. I mean, I'll probably care later, but the weight of the robot is going to be so low, a flat tire probably won't even make a difference. Might be better, give it a little better traction and soften the ride up a little bit. So it would be kind of funny to run it, just purposely run the robot with flat tires. Make it less bouncy, I guess. Anyway, so this being a metric setup, the bolts that go through it, in this case, are use a 13mm wrench or socket. Come loose. I have taken one of these apart before. Oh, there's something to remember. Make sure your tire is deflated when you're taking this apart, because this is basically a split rim design. So this is 2 halves, and this is kind of part, I think part of their design. Just take the bolts out, pull the wheel halves apart, it makes it easier to take the wheel apart, and then to get to the, like to change the tire or change the tube or something like that. Well, if this is inflated, I completely missed this the first time, and I know better. I used to work on things like aircraft wheels that are split rims. Little tiny lock washer on that, try not to lose it. Anyway, if you take a wheel apart that's inflated, it could kill you, literally. Now these probably not, because they wouldn't be over 10 psi, but the aircraft wheels are a couple hundred psi. So yeah, that could make a dent in your head if various parts decided to come out at you. Trying to lose that one. Sometimes I think I could replace the top on these workbenches, but why? I mean, yes, it would be smart to get rid of all the slivers. That would be nice. So that's what it looks like. So I could put the bolts back in. I probably will need longer bolts. I figured it would be a starting point anyway. My holes are just a little bit tight. When I 3D printed them, they're a little bit small. So yeah, this just comes apart. A person actually could completely 3D print their own wheel hub. I mean, this is not going to have very much weight on it, so that might be an option. It would be kind of cool to make, for instance, you could make a wheel hub that looked like the Mars Rover wheels, right? That'd be kind of cool. And then paint them silver so it looked like they're made out of aluminum or something like that. Hadn't even thought of that. This might be fused on here. It looks like they spot welded the center into it, so I don't think it would be easily removed. But it hadn't even, I hadn't even considered making a new one. Oh, I see how I hadn't noticed this before. The bearing, inner and outer bearing, are part of this. This part is just the disc. It doesn't have the bearings in it. Okay, so if you remade this and put your own bearings in it, you could do that. Something to think about. Maybe not the best way to do it in the end, but what I came up with. Grab my calipers, which don't have a battery in them because it always goes dead. Measured the bolt, and then lock the calipers. And then just kind of started grabbing drill bits. This one is slightly too big, but pretty close, which is fine. I need a clearance hole. I don't want it to be too tight going together. So I just grabbed a bit that was about the right size. Didn't even look at what size it was. And all my bits are imperial. I could also read the caliper, but it's probably 5/16, I think. I don't have any metric bits, so I can't do that. I should wear eye protection, but this is plastic, so it probably won't kill me. Do one to see. Oh yeah, way better. This is still kind of a common problem that I'm relearning how to deal with on 3D printing. The 3D printer slicer software is pretty good at outside dimensions, but sometimes it pads the inside of the hole too much. And it's just a matter of, well, that's kind of how the software is set up. On the plus side, it makes it easy then. You can just re-drill the hole if you want to, right? But if you're off by too much, you'll end up drilling into the infill. If you've ever looked at how a 3D printer works, the outer surface of the part is nice and solid plastic, but the inner part is partially hollow basically to save time and to save plastic. So if I drilled the hole the next size bigger, I might burn through the plastic and then get into the infill, which would have like no strength at all, basically. Let's see how I did here. Okay, that probably isn't going to work because the bolts just aren't quite long enough. So for today, it's like, well, let's start with the parts that I've already made. This is basically it. And mock it up and then see how much room I have could I take that windshield wiper motor and find a spot to put it where it would actually reach without being in the way of something, you know, because I'm using something that wasn't made to use in that way. Oh, you know what, if I take the lock washer out, I'll have an easier time. For now, that'll be fine. I left the cutouts so that the socket would reach in there. Almost didn't, basically forgot. And then I was thinking about the next step. This is the thing, is I'm not smart enough to think 3 or 4 steps ahead yet. As you do this, you get smarter, hopefully. But I hadn't, you know, if you were really smart, you'd sit there and make every part all the way down the line in CAD and make sure that they all look like they fit together before you started making the parts in the real world. That's the smart way to do it. But I knew I had a pretty good lead time. It's like I wanted to get one part figured out, and at that, you know, that day I didn't know what motor I was going to use. I still don't really know what motor I'm going to use. Am I going to use the wiper motor or not? You know, that kind of thing. I've also got some really little motors that I think are going to be ridiculously too small. But if I only go, my design idea was 3 miles an hour, basically a walking speed is maximum speed for this. And I'm not going to have very much weight in the beginning. I can probably run a fairly small battery. If I do solar, which I would like to do solar, they don't weigh very much. Okay. Also, if I do solar, I don't need as much battery. Okay, I don't need a great big heavy battery if I've got solar also working. Okay, these are plastic parts, so do not overcrank them. Just a little bit. But yeah, if I do this too much, I will break them. Shouldn't even use the wrench. I printed these with ABS, so it's fairly durable. A lot of people use PLA. I don't know that I ever used PLA, even in the beginning. I just decided I'm going to make everything out of ABS. I used to do a lot of 3D printing projects when I lived in Austin. Partially because I had enough power to do it. It's actually a big reason. Yeah, these are just a little bit more than finger tight. Also, it doesn't look like it quite centered up on the hub, but it's pretty close. There's a little bit of an off center. I don't care, really. Man, I got it about nailed down. Okay, well, we could fix that with the spacer too. Depending on how I lay out the next part. Looking at this, I could knock about 1/4 of an inch off of that, but I like that it sticks out a little bit. All I'd have to do is add a spacer in here to offset this. So if I built if I made my sprocket such that it bolted onto here and then came out, I just got to make sure it doesn't hit here, but the sprocket could also have a spacer. The sprocket would be narrower than my finger. That's about how big it is. It's the belt is 6 millimeters, I think. So 1/2 centimeter-ish, 2.5 centimeters to an inch, so do the math. Somewhere in the neighborhood of 1/4 of an inch, something like that. That's close enough. Okay, so if I put my nut on the outside, with these bolts that I've got a bunch of, these are bolts left over from the turtle project, so I know I've got plenty of those, so this would work. Okay, this is a starting point. So these parts could work together, so if I then made, what I would do, make the sprocket, inner dimension of the sprocket stop here. Then I'd have room to put a steel bushing in between to give me space. The sprocket would be outside of the bushing, attached to the wheel, and then it would extend out. I want to extend the sprocket out maybe 6 inches or something like that. Probably more than the size of the wheel here. Then I'll have a belt come out to somewhere on a point here, you know, somewhere convenient, doesn't really matter. And it would be a little tiny sprocket on the end here, sitting about here, so I could mount the motor to this, and the little sprocket would turn about 10 times, and the big sprocket would turn 1 time. That would give me 10-to-1 reduction, for instance, which I want to go slow. I don't want to go too fast, so going slow would be completely fine. Then the final difference I could make up with that speed controller that we played with earlier. So I could then adjust the speed, and then when we get to the software stage, I could just say max speed equals X, and we could change that in software so that we just don't go too fast. But in the beginning, it would be nice if my maximum speed for the motor was about the right speed, so then get the gearing right. Yeah. Another possibility that I have considered, this drill has a high and low transmission built in. I've seen these available, the motor with the transmission, which would be a really cool setup if I could do that, because I could run an electronic speed control to drive this motor instead of the switch. The forward and reverse is electrical on this. My speed controller can do that. We already saw that. We can run that fan backwards and forward. If I had a mechanical transmission built into this, that would be the coolest thing ever, because if I could flip a switch remotely and tell the robot to go into low range before it got to the hill, right? That would probably cost me about $40 or $50 per wheel from what I've seen. I might be able to find cheaper ones. Or you can buy used tools and just pull them apart. And I've been looking at that as an option. You know, I've got several of these, but none of them quite match. 3 of them are impact drivers. 1 is a drill with a chuck, and 1 is a drill with just a quick release bit on it. But some of them have high and low range on them. So that was kind of what got me thinking about it, is either get a gearbox that's on the motor, or do the big sprocket gear reduction, or probably both at the same time, is how it ends up working. Cool. Alright, this battery's just about to go dead, so let's just stop there. Okay, battery might go dead. We'll try to go fast. Just kind of for today, I'm just trying to mock it up to get a feel for how this is going to look. This is the wiper motor. I would need a mounting plate that picks up these 3 bolt holes, and then set that. We would take this arm off too, by the way, but the arm is about how the sprocket would be attached. Also, to clear the bolts, we'll probably need to step it out, so we could make a sprocket that was maybe out here, and then the center of the sprocket could kind of dish in to pick up the mounting. I haven't looked yet. This may or may not have a flat side on. I don't think it does have a flat side. They might have tapered the shaft, so we'll work through that later. But the idea would be, we could set one motor here with the sprocket that would drive to here, and then on the opposite side we just turn the motor 180 degrees and set it in the same spot opposite side. And if you get it right, it's like it doesn't matter where the sprocket and the belt goes, which direction. It could go forward or go back, as long as it spins the right direction. But by doing it this way, I've got the weight of the motor kind of right over the axle, which gives me a little bit more weight for traction. Okay. If I put the motor way out here, that might pull the back down or make the front too heavy, but if I put the motor right here, that would give me good traction. I could also set the motor vertically and then have my sprocket up here. You know, so I might play around with different options there. But if I do it this way, I can make my mounting points right on that chassis that I've already got. Right. Now this may or may not get used very much, this piece, but I think this would be a really good starting point. Because what I was thinking is, set up 2 wheels, 2 motors, because I've got 2 motors. I've got 6 wheels, but I've only got 2 of these motors right now. But I could build this adapter that I already made out of plastic. I could make my first set of sprockets. I could mount this. I could weld a tab to here to mount the motor to. And then I've got the wired connections right there. I could make a 2-wheel robot that I could test with. It's not going to have self-balancing or anything. But what I was thinking for the first test what if I made a hitch for this piece that would just go right on the front of the hitch here, and then with forget about steering or anything. We'll just say, okay, motor goes forward, so it would just sit there and pull the wagon forward. I could sit the batteries in the back. I could have payload if I wanted to, but for the beginning, just a way to see, does that motor have enough torque, which I think it does, and can I get the speed in the right range to be useful? Also, at that point, if I set up different drive speeds, I could have 2 channels driving, one driving each motor, so I could set a different speed for each motor. That's coming, so that's the next step. 2 motors, 2 sets of drive, 2 motor, 2 speed controllers, then I could remotely control it. If I had that hitch set up to pivot here, I could drive forward, I could stop, I could have one wheel turn one way, one turn the other way, the little front would pivot. It wouldn't have to worry about balancing because basically the trailer would balance it, right? So we'd have the little donkey here pulling the wagon, basically. And all it would have to do is just do a pivot turn like a skid steer, turn itself, and then drive forward, and then the wagon would follow it. And that would be it. That would have a really good starting point to then we could start testing. We could on that, we could test the radio controller, the motors, the battery, the speed controllers, right? Plus we could use that for a test platform to then put cameras on. Okay, and then we could have it drive back and forth on the driveway and see how far can I drive on this size of a battery before it goes dead, or how far can I drive before the transmitter doesn't connect to it anymore. Okay, so we'd have a really legit, useful little robot to test with while we're building the big one. Plus, I could then put, how many miles can I put on these plastic parts before they break? At the moment, this is the best I can do. Later on, it would be really neat to make that out of metal. But it's not practical right now to make it out of metal where I can knock that out. Well, it still took me 4 hours to make that on the 3D printer. It's a pretty good sized part. So that's basically, I can make one of those on a sunny day, and that's it. I'd have to wait for the next sunny day to make the next one. I can't print 8 hours a day. I don't have enough sunlight or batteries right now. So that's kind of one of the issues. But in the beginning, that's how you start. If this was a commercial venture, if I had people lined up to buy these, then we could make improvements. But for now, this is where we're at. But that's basically it. And this gives me what I needed to know. I can make a sprocket, I can make a sprocket, and I can make an adapter and mount this right to this piece, and then we're set. So that gives me something for today and tomorrow, and then we'll come back when we get that done. But that's a good first day.